Welcome to Brain Vision.
So a photon strikes a deuteron, splitting it into a photon and neutron, and we're asked to calculate the kinetic energy that's released in this interaction. So since we know the wavelength of the photon and it's given in the problem, we can quickly calculate the energy of the photon, which is given by the expression hc over lambda, where h is Planck's constant and lambda is the wavelength of the photon. Plugging in our numbers and being careful with the units, we find that this is equal to 5.68 times 10 to the minus 13 joules of energy. Now, we can look up the binding energy of deuteron, so the binding energy, and we can find that this is equal to 2.224 mega electron volts. Now, since the proton strikes the deuteron and splits it, this binding energy is released, and the kinetic energy released is the difference between the energy of the photon, which is destroyed, and the binding energy of the deuteron. So delta E is simply E pho, energy of the photon, minus EB, the binding energy of the deuteron. And this is a value of 1.32 mega electron volts. And this is the kinetic energy that is released. Now, to calculate the speeds after photodisintegration, we can use the fact that the kinetic energy is equal to 1/2 mv squared. Now we simply solve for v, which is twice the kinetic energy, over the mass, which we take to be 1 atomic mass unit for each of the two sections. And plugging in numbers, we get a value of 1.13 times 10 to the 7 meters per second. And those are our final answers.